will now be recorded.
Yeah, let me start. Yeah. In this session, guys, we shall try to discuss the very important functions. We have seen in the last session about the anonymous functions, named functions, higher order functions. This session, we shall try to discuss about the very important functions, guys. That is called as partially applied functions. It is very important, guys. Okay, so if you see the application of those partial applied function, really we feel to what extent these functions will be useful. They may seem to be they are very not that much useful, but when we see actually implementation of them, really we feel very wondered, actually, because they're very important functions. Okay, let's try to see them and how they will work, and how we have to use them, how to create them. Okay, so then how do we define a function? Generally we use the keyword def to name a function and to start a function creation. We can also start without have a function, without having the keyword def. Also we can use val, or we can create a function without a name also. That's also possible, but generally it's a good practice to have a name for a function so that it can be reused. Equal to generally we write like this, x colon int some y colon int, and this is going to the result type, equal to, and we mention that the logic here. What is the logic that would like to implement? That logic we are going to implement here. Let me simply say x plus y. This is one function. Okay, so when we create a function like this, next, how we are using this function, that matters a lot, guys. Just we have created a function, that's fine here. The next point is how we are passing the data to this function. That's very important. Based on that only we call the function as partially applied function. Okay, so this function is designed in such a way that it has to accept input. What is that input? That input is made up of two parameters or two arguments. X is one argument and y is one argument. So this function has to take two arguments, x and y, and it has to generate one integer as output, that is x plus y. Okay, this is the purpose of this function. Then how do we pass the data to this function, guys? The input values, the function name dot 2 dot 1, something like this. So it is going to give the result as the sum of 2 and 1, so we get 3. Okay, what about suppose I do not want to supply the two values at a time. I would like to supply only one value now. Later I will supply the second value. The second value can be x or y. The first value can be x or y. It can be anything. So that is the very simple here. Instead of passing all the inputs, it requires, this function requires two integers to be given as input, isn't it? So instead of giving all the inputs at a time, we give only some of the inputs. That is called as partial. They call a partial input. Okay, so instead of supplying all the inputs at a time, we supply only partial input, that is only some of the inputs. Not inputs, I don't say, some of the input arguments. In that case, the function that will be created will be called as a partially applied function. Let me show you that. While some mm, mm, let me say a1 equal to f1 of 2, f1 of 2. This is the first value we are submitting, but I am not submitting the second value. Simply I am saying that I am not supplying the second value. Simply I am just passing underscore. Under the sense, I am not supplying any value now, guys. Just assume it as submitted, just it is underscore, that's it. Okay, so this is going to create a partially applied function, guys. Okay, so what is this is doing here? This step is actually creating a function again. Okay, and for that function we are creating a reference called as a1. That's it, very simple. Okay, this f1 of 2, this is fully, we are supplying the two parameters, we are supplying two arguments. But here in this case we are not supplying the two arguments, we are supplying only one argument. What is that argument? First argument we are supplying, that is 2, that is for x, and for y we are not submitting any value. So what is that happening now? This statement, whatever we have written here, f1 of 2 comma underscore colon int, it is going to create a function called as partially applied function. Partial applied function is very, very important, guys. Very important. Told you, as already I told you, very, very important. Okay, f1 of 2 comma underscore int. Similarly, not only x, I can skip x. That is the first argument. I can pass the second argument. I can skip the first argument, I can go with the second argument. How do I do it? I can do like that. Well, a2 equal to f1 of, I want to skip the first argument. I do not want to pass the first argument value. I would like to pass second argument value. So I can do like this, sorry, underscore colon int. So its type is int, right? It is an integer type. And I would like to supply the second argument. Okay. This is, guys, so even this is going to create a function called as partially applied function. Okay, this is going to create a function called as partially applied function. So you have to remember. Okay, but how to pass the second argument, when to pass the second argument, how to pass the second argument? So this, guys, for a1, so this, for this already one argument is passed here, 2 is passed, but there pass second argument. So if I provide 4 or some 5, so this set 5 will be the second argument, guys. So for already, here we have submitted 2 is passed here. Now we need to supply one more argument. Now with this, if we try to provide like, if we write like this 5 will become the missing argument. Whatever the argument that is missing, that our missing argument will be this 5, guys. It's very simple. Okay, you see this, see this now. A1 of 5. What is the result we got here? 7. How come we got 7 here? This is the addition of 2. Already we have supplied 2, right? That is being referenced by A1. And for this 2, this 5, that is, we are supplying this 5, the second argument. So what is the logic of this F1? If you pass 2 and 5, so 2 and 5 must be added. That's it. Because of that, we got 7. Okay. Similarly, A2 of, if I pass some 100, so what has to be the output now, guys, here? What has to be the output here? So A2, this is the A2, and for this we have supplied already one value, one argument as 4. That is the second argument. Now with this 100 will be substituted as the first argument. Okay, this 100 is going to be submitted to the first argument. There are, after which the addition will be performed between 100 and 4. We get the result as 104, guys. It's very simple. Got it? So instead of providing to all the arguments at a time, we provide only partial arguments. Partial in the sense one or more. Here we have only 2. That is the reason we have supplied only 1. Okay, is this clear, guys? Any questions on this? We'll see what is the we'll try to explain an example where it can be, we'll understand easily about it. But this is how it works. Is it fine, guys? Any questions on this? Yeah. Let me create another function. Def f3 is x colon int, y colon int, and z colon int. So here I am taking 3 variables, not just 2 arguments. I am taking 3 arguments, x, y, and z. Okay. So let me take int. Okay, let me take just x plus y plus z. And x minus y minus z by x minus y minus z. Okay, this is a function, guys, we have created. Now we shall try to pass the arguments to this partially, not totally, partially. If we try to pass the arguments totally, how we have to pass? F3 of what? 2, 3, 4. So 2 will be substituted for x, 3 will be substituted for y, and 4 will be substituted for z. So what has to be the result, guys? If you pass 2, 3 and 4, 2 plus 3 plus 4, that would be 9 by 2 minus 3 minus 4. What is that? 2 minus 3 minus 1 minus 1 minus 4, it would be called minus 5. So 9 by minus 5. What is the result, guys? I think it is, is it 1? Let me check. Yeah, minus 1. It is minus 1, not 1, it is minus 1. Okay, so 2, 3 and 4. So how to pass the values? Now we shall try to pass, we shall not try to pass all the arguments at a time. We shall try to pass only one argument. Okay, we shall try to pass only one argument. So how do we pass it? Is see this one. Val b1 equal to f3 f3 of now I will pass only one argument. The first I will pass the first argument. Let's say 2, but I do not want to pass two arguments right now. I would like to pass the remaining two arguments later. I would like to pass the remaining two arguments later. So how shall I deal with it? So underscore colon int. Next again underscore colon int. That's it, guys. Okay. So what's happening here? This f3 is creating a partially applied function. This f3, this statement, what are the statement we have in f3 of 2 the comma underscore colon int underscore colon int? This is going to create a partially applied function. Okay, now what is that we are trying to see? Just observe now here again here. Well, b3 equal to or b2, let me take b2 equal to b1 of, so already for this, guys, one value is submitted already here. How many how many arguments are missing here? Two arguments are missing. So I can pass two arguments here, or I can pass only one argument here. See this, 3 int colon not underscore colon int. Okay, this is going to create another, what I call it as partial applied function. Okay, so with this statement, I passed only one argument. We have passed only one argument to the function, and with this function, how many we have passed till now? We have passed 2. Here we have passed one argument, and the second argument is passed here, and one more argument is left over. One more argument is left over. Now see that what I am trying to do now. While b3 equal to b2 of, so how many arguments are left over till now? Only one argument is left over. So I can pass that argument now directly like this. So what is it we got? I can now get the result. We passed all the values at a time here, 2, 3 and 4. What's the result we got? -1. The same result we got, from these 3 steps. Is it clear, guys? So instead of passing all the arguments at a time, we are passing one by one. That's it, very simple. That is one by one we are passing the arguments. So whether we pass all the arguments at a time or one by one, not one by one, we can pass two arguments at a time, one argument, and we can pass only one argument in the beginning, or we can pass two arguments at a time. It need not be, as we have here 3 arguments, it need not be one by one. We can pass at a time 2, we can pass at a time 3, no, at a time 1, and after that 2. We can pass, we can use any, that is, we can pass any number of arguments. Is clear, guys? So see, this is how this partially applied functions are getting created, how they are working. This is very important. Clear, guys? Any questions on this? So need not be always 2 arguments. It can be 3 arguments or 4 arguments or 5 arguments. Any number of arguments can be there. The partially applied functions. Okay, now is it fine, guys? Any questions here? Yeah, Raviteja, Anurag, Hina, Lakshman. Do you have any questions, guys, in this? You have to understand, guys. You have to understand this point. Okay, partially applied functions. So f21 was one function and f3 is another function. For that we are passing the data echo. In the declaration of the function, there will not be any difference. There will not be any difference in the declaration of the functions. Okay, only the way in which we are supplying the data to that function. Based on that only we call the functions as partially applied or fully supplied. Okay, partially applied or fully applied functions. Fully applied in the sense we supply all the arguments at a time. Okay, and if it is partially applied, we supply only partial arguments, not all arguments. Partial in the sense some will be there, some we provide some, and some will be missing. Those are partially applied. Fine, guys. Now I will try to say now where actually these will be used. Actually, I'll show a simple example, guys. It will be very very useful. Very simple example where these will be useful. Okay, let me show you that. Suppose, guys, um, what I am doing is, let's say there's some shop is there, some shop, some store. It may be a bookstore, or it can be some cloth store, or it can be any store. Okay, so let me just write it simply here. So there is some store, guys. It can be some, let's say some bookstore. Okay, so that the vendor of the books, okay, the store guy wants to give a discount on every book. He wants to give a discount on every book. So how much discount he wants to give? Let's say he wants to give some 10% discount on every book, guys. Okay, suppose if a book one, if its price is some $100, let's say, not $100, let's say $10 or 100. Let me take $100, not a problem. Just for just for example, I'm taking $100. So if the actual price of a book is $100, okay, so he has to give a discount of 10%. So 10% is how many dollars, guys? So how do we get it? How to get the what do you call as $10? How do we calculate $10? Get the 10% of it. There's how do we calculate? There's a discount. Discount is 10%. So 10% in the sense how much we are going to get here. So how do we get it? That is, how do we calculate it? So actual price, is it? So actual price into 10 by 100. Do you agree with this, guys? Is it fine? Actual price into 10 by 100. Is it okay? Is it fine? 0.1. Is it fine? Correct enough? Yes, that's fine. So we are going to get 10. And what will be the price that must be charged to the customer? So for the customer, what has to be the what the store guy has to charge? Actual price minus discount price, isn't it? Actual price minus discount price. So this is the amount the store guy will collect from the customer. So each book will have an actual price, and if it is $150, he has to calculate the discount. If it is $120, if it is some 100, 200, 5, 10, 12, whatever it may be, whatever the number of actual price of the book. So for on each book the percentage of 10% has to be calculated, and this 10% amount has to be deducted from the actual price. So we get the price that must be collected from the customer. Did you get this this situation, guys? Here, what is that we are expecting, and what is that has to be done here? So how many what is that we have to provide actually, guys? We have to provide actual price first. So this actual price is going to play an important role here. So if you provide actual price, we can calculate the discount price out of it. So how much discount price? Some 10, as we are taking 10%. So if it is 10%, then we can calculate based on the actual price. We can calculate discount, and we can get the total. The actual price that must be collected from the customer. So this how we are going to implement by using partial applied function. Just observe, guys, is very important. It's very important. Okay, let's see this now. Okay, now what I do is I write a function for this def. Let me call it as book. So what is that we need to provide, guys? Here, what is that we need to provide, guys? We need to provide actual price and discount price. Do we provide discount price here? No, the discount has to be calculated, isn't it? The discount has to be calculated. So actual price. So let me take all these as doubles. Okay. Why? Because the chance of getting the we call as this rational numbers. So let me take actual prices for double and discount. Discount we don't pass. Discount percentage. Discount percent. So it will be integer only. Discount price will be always integer only. Percent, I'm talking about the percent. I'm not calculating the discount. I'm not passing the discount price directly. I'm passing only the percent. So depending upon the percent, the discount price has to be calculated. Okay. Let me take, it would be integer. So we don't have 10.5% discount, 2.5% discount, right? Okay, let us take that also. Not a problem. Let us take it as double. Someday it's also possible, right? So what is that we have to return actually? So after we have actual price and discount percent. So what is that we have to get? We have to get the amount that has to the price that must be collected from the customer. That is even that will be double. The return type will be equal to double equal to now while customer price. I call it as customer price equal to, you want to tell me guys how to calculate the customer price here? So first let me calculate discount price first. Discount price equal to, how do I get the discount price guys? Actual price, actual price into discount percent. If it is 10%, discount percent by 100, isn't it? So discount price equal to actual price into discount price by 100. Next, well, customer price equal to, so what is that I get now? Actual price minus discount price. Is it fine guys? Any doubt in this? So finally I have to return customer price. Customer price. Is it fine guys? Any mistakes? So we are just taking two values guys, actual price and discount percent. Okay, not the price, discount price. Based on the percent we are calculating the discount price, and with the discount price we are calculating the customer price, actual price minus discount price. Okay, and close it. Got it guys? This is the function we have written here. Now we need to pass actual price and discount percent. So here actual price and discount price also not fixed. The discount price will be calculated based on the discount percent. Okay, now let me take, well, customer, let's take customer 1, the C1 underscore 1 equal to, I take okay, no problem, let me take underscore 1, but it is not preferred to use underscore in the naming convention of any variable or definition guys. Why? Because underscore has certain meaning, right? So is not preferred to use underscore 1. So let me take C11 equal to what's the function here? Book of so let me first pass all the values at a time. So what is the result? So let's say $100 and percent is 10%. The actual price is $100, the percent is 10%. So what has to be the total amount that must be charged to the customer guys? What has to be that? 100 is the dollars, 100, let's $100 and then 90, right? Isn't it? We have to get 90. That's what we got. Okay, this is working fine now. Now we shall pass these two values not at a time. We shall not pass these two values at a time. Why? Because guys, today the discount is 10%. When you go to any store, we won't have same percent on all the books, on all the products, if you observe clearly. So 10% discount on this, and a 20% on this. And if you purchase, let's say some, if you purchase, if you find, if you make a, what you call as bill of $500, the amount of discount will be more. If you make less, what you call as shopping, then the amount of discount will be less. So discount price also, discount percent also changes, isn't it, depending upon the what you call as shopping we make, the number of the amount we make in shopping, in buying that product. So always the discount price percent also changes. So discount price is not static here, it is dynamic, it changes. So actual price also changes. So how do we pass it? So how do we pass? Now I want to pass only actual price, guys. I want to pass only actual price. Later, depending upon the season, depending upon the demand, I would like to decide discount price on it. Okay, so what I do is, while some b1 equal to uh, on book one, I would like to pass only the actual price now. Later, I will decide what has to the discount percent on it. Okay, later I will decide what has to be the discount percent on it. Depending upon the demand, I will decide. Okay, so book of so let's say if it is $250, and I don't pass, what, underscore colon double, right, so double. So I don't pass the what is it called as the discount percent now, I will decide later, but actual price is $250. Okay, that's I'm discussing. Okay, now so depending upon the demand, what I have done is I made decision that I shall not give more than 5.6, let's say 6%. I would like to give only 6%. What is that discount on this book, which is of $250. So I pass only 6%. So now I will get the amount that must be charged to the customer, taking the 6% away. So what will be the total charge? Now it will be $235. Now my season has changed. My season got changed. Now I would like to give. The season is dull. So in that case, what I do is I would like to give some 11% or 11.5% on that book. So 11.5, let us say. So it is going to give the amount that must be collected from the customer. It is 221.25. Guys, are you able to understand this? So we fix some value, and other value will be always changing, isn't it, depending upon the requirement. The second value is getting, it's dynamic, is not static always. So in that case, this partial applied functions will be very, very useful. That is, we don't know what the second value is. We're not sure what second value is always. So it may change dynamically. So how do we decide it? So that will be decided dynamically. So when we provide the second value, then we have to get the actual result. So this is one of the use cases, guys. Got it? Okay. Now this we are fixing the actual price. We are making it as static, and that is fixed. Now in the second case, what I can do is I can fix the percent fixed, discount percent fixed, and I would like to pass the book rate. There is the actual price of the book, then I have to get the discount price. Even that can be done. Okay, so val b2 equal to book of so let me skip this, not int, it is double, right? Double, both are double. And the percentage, the discount percent for the entire month, for this entire month, discount price is let's say some what shall I pass, the some 12.3, let's say the percentage is 12.3. Okay, so here we have passed only the discount price, but we did not pass the actual price. So if we provide the actual price, we have to get the price that must be collected from the customer. Okay, so how do we pass it? B2, the price of a book is $150. So this $150 for this 12.3% of price will be calculated, and we get that will be deducted from 150, and we get the price that must be collected from the customer. What is that? So out of 150, after giving the discount, after waiving the discount price, uh, the shopkeeper will charge $131.55 price. Okay, and B2 of some 400 or 420 is going to give some 368.34, like this, guys. You got, how we are applying this function. Clear, guys? Any questions in this?
Sir,
Yeah, yeah.
I have a case here.
Yeah.
Let's take, we have three parameters. One is a day, which day, and percentage and amount. If uh, uh, book cost is fixed, and if I want to pass this remaining two parameters like day and percentage,
Mm.
can I do this with this function, sir?
Yes, we can do. We can pass one more argument. Let's do that. DEF. Let me call it as mm, book day. Book day wise. Okay. Let me call it something like that. Device. Use this convention, guys. Okay. Always, if we are when we're naming, when we're creating a function, use this convention of naming the function. So this is called a lower camel case. Okay. The first word starts with lowercase letter, and the remaining words start with uppercase letter. Okay. Bookwise of. So what is it you want to pass here? Actual price, guys. Actual price, right? Actual price would be double, and discount percent. Discount percent. And it is also double, right? Then what is that you would like to pass? What is that you want? Huh?
Day,
Day.
day actually.
Let's say day. Shall we take it as integer 1 to 7, right? We have 7 days in a week, so let's take integer. Okay. Yeah. What is that we have written? We have written the price, right? Actual the price that has to be collected from the customer. So even that will
Double.
be double. That will be double only. Yeah. Now, first let us calculate. What is that? Mm, the discount price first. Okay, depending upon the day, how much we have to use, that we have to decide. Okay, less now. Case, not case. Day, right? Day match. Case
Okay.
one. Case one implies. So if it is case one, that in the sense day one. If it is day one, how do we calculate that percent, that customer price? So first I calculate well discount to price. Discount price equal to, how do we calculate discount price, guys? Actual price into discount percent. Sorry, discount discount price. Sorry, percent. Sorry, discount percent by 100, isn't it? Thus we get the discount price. And after this, how do we get this customer price? USTOMER customer price equal to actual price minus discount price. Okay, and finally we have to return customer price. Got it? Actual price minus discount price, and finally customer price. And next, if it is case 2, if the day is 2, uh, mm, so actually we need to something, right? If it is day one, the percent we have decided the percentage, right? The discount percent we have to decide actually. Based on that, so what is the type shall do now? Let us. Mm, it will be same. If you write the same, the logic is going to be same. So discount percent based on date we are deciding, right? Um, It's not a problem, guys. No need not to pass this case also, not required. Mm, just let me close this first. Yeah, let me write this again. Even this is not required. This case is also not required. Directly we can write it. Directly I can write. It's not required. We are passing the day also dynamically. We are not doing that. Um, val discount price equal to, and val customer price equal to discount price, and finally customer price. Close this. Okay. Now I say val sum C11 equal to book day wise. Day wise. Book day wise, and I pass only the price. Let's say price some $200, and I would like to pass underscore colon double. There's a percentage, right? Percentage and day. Let's say what do you want the date to be passed here? We get directly, guys. It is not required also. Actually, we can pass everything directly. 200, and with the percentage is 20%, 20.5, let us say percent, and it is day one. We get the same result, but it's not like this. So, what is the percentage you want for day one, guy? Day one, as a kid, you did not mention that. Day one, how much percent? Day two, how much percent? Day three, how much percent? You did not mention it.
And any percentage will get just 1% sample example.
Okay, fine, fine, no problem. Just let me make changes to this program. So day match. If it is case one, what I do is case one. In that case, what I do is um, okay, that's fine. Let me take this case one. Yes, case one. So what I do is discount percent. Uh, in that case, discount percent need not be submitted from this, right? It is not required. So let me check. Let me just do it. Day one, case one, case one implies discount price, discount percent. Mm, 1 second, guys. They're not required. Just let me do it 1 second. Here we need not to pass the discount percent in this case. Only day is required. Actual price. That's it. Now I like this. Day match. In this case, one is the first day. Then what I do is val discount price, not discount, percent equal to, let's say, some 10%. So if it is the first day, so I'm taking it as 10%, 10.0. Okay, na? And I'm calculating discount price now. Discount price equal to how do you get discount price? Actual price into discount price, discount percent by 100. And how do you get customer price? Customer price equal to actual price minus discount price, and finally we get a customer price. This for case one. This for case two. Uh, is a case two. Then val discount. I shall go with only two cases here. Later we can add if you want them. Okay. Percent equal to some. I'm giving some 15% on second day. Day two I'm giving so discount price discount percent at 15%. Now again I get val discount price equal to actual price into discount percent uh, by 100. Get this, and val discount. at customer price, actual price minus discount price, and final return customer price. It's done, I think. One more brief is required. Just close it. Okay. Now, if I pass val some, so let me call it as C1 equal to book day wise of. So first I pass only what is called as 200. Let's say 200. I would like to pass the first argument, and the second argument I would like to skip for now. This day I would like to skip for now. So how do I skip it? Underscore colon. Its type is integer, isn't it? Yeah. Now C1 of. So now in the day one, if I pass one, what has to be the person? What has to be the customer price guys now? See, one in the sense case one we are giving 10% discount. So if it's 200, what is the 10% after waiving 10% of amount? So what is that we get here? 200 10%. How much we have to get? 200 minus 10%. How much we get? 180, right?
180.
200 minus 20. We
180.
have to get 180. That's what we got. Okay. So if it is suite 2, that is day 2. So it has to 15%. 15 in the sense 15 into 230. So that would be 170. Right? Is it fine? Zakir, no? This is how we can decide, depending upon the day. Clear? Hello? Is clear, Zakir? What is
Yes,
it?
sir. Yes, sir. It's
Yeah.
clear.
No, we can use any any number of arguments, any type of arguments. We can pass anything here. Okay, that we decided. Fine. Okay. So this is the very I told you in the beginning session, sir. This is very important, guys. This partial are very very important. We need to understand them actually. We need to understand. If we try to go with some multiple, whatever the question he has now, try to implement some such kind of scenarios. So once you get idea of this, where they will be used actually, how they will be used, we'll understand them. Why? Because I told in the yesterday in the Spark session we have discussed about catalyst optimization, right? So in the catalyst optimization, in the background, in the implementation, it is going to make use of this functions only, guys. It uses this partial applied functions there. Okay, so we shall see that in the Spark session we'll discuss about it. But this is how we create a partially applied function, right? Now there's one more type of function, guys, here. Not function, not the type of function actually. That concept is called as currying. Currying. This is the concept. It's called as currying. Currying. So what is that? Let me just. It's very simple. Let me just show you that. Def f4 x colon int comma y colon int. This is how we are writing simple function, isn't it? This is the habit of we are writing a function till now. Okay, but we can write a function like this also. Df f5. So here we are passing two arguments to this function, isn't it? We are passing two arguments. So I can split these two arguments into two inputs. So we are passing two arguments as single input. Okay, we are passing two arguments as single input. We can pass these two arguments as two different inputs. Let me show you that. X colon int, close it, and y colon int. Okay, colon int. Integer, it is a return result type. I can do the same thing again here. This concept is called actually currying, guys. Currying in the sense, splitting the input arguments into separate input sets, separate inputs, individual inputs. This concept is called very simple, called as a currying. This is called as currying, currying of this function. This is a curried version, and this is the normal version of writing a function. Very simple. Then how do we make a call to this function? How do we call supply the data to this function f5? See, for f4, how do we pass the two values at a time? We can pass 2, 3 like this. Or if it is partial applied function, how do we supply? We wave 4 of some 2 comma underscore colon int and followed by some, let us say, some 3. So we get the something wrong here. Yeah, first we have to take it as a value first, while some a1 equal to this and a1 of some 3. So we get the value 5, 2 plus 3. So this is how we said just now how to pass the data to this function. Similarly, for this f5, how do we pass the data? How do we pass the data to it? It's very simple. f5 of 2 comma 3. We can't pass like this. We can't pass like this directly. We pass like this. See here, f5 of 2 followed by 3. This is how we pass 2 and 3. Okay, so now we get the same result 5. The result will be same, but here we can pass the arguments or we can skip the arguments like if we have skipped for partial applied functions. Now we also we can make this function fi also partially applied. How to make it is very simple. See this, while some a2 equal to fi of 2 and second argument, I would like to skip the second argument underscore colon int. This will create again a partial applied function. Now I can pass a2 of some 5. So 2 plus 5, it must be equal to 7 now. Yeah, this is how we can use this. Okay, I will try to explain what is the purpose of it. I will try to explain a use case like this. I have explained for this that partial applied function, where to actually use this currying, where this currying will be useful. That I will try to explain the next session. But this is what this is how we can create implement the concept of currying in Scala language. It's very simple, guys. It's very simple. Simply we have to pass the data to it, nothing else. We pass the input arguments separately, as separate arguments. If we have one argument, only one input. If we have two arguments, we pass them as two inputs, so two separate inputs, what we call as sets. This concept is called very simple, called as currying. currying, currying. Okay, na? Is it clear, guys? Fine. Next, let me give a quick idea of another one is a pure function. A pure function. Okay, let me just show you that. Very simple. After that, I will try to wind up this. See this, where some a equal to 10, or let me take it 100. Next, I am writing a function. See this, guys, here df m1 of x colon int equal to val r1 equal to m1 plus a I use a equal to m1 plus a, return a. Something wrong here. M1, sorry, not M1, sorry guys, it must be x, I forgot here. M1 and a plus x plus a. I return a, or this is one again. Let me use like this, a plus x plus a and return x. Okay, now I'm passing m1 of 20, guys. What the result? We got 20. m1 of 20, I got the result as 20. m1 of 30, 30, and m1 of 20 again pass the value, we got 20 again, and m1 of some 40, 40 again, 40 again, 40 again, 40 again, 40 again, 40 again. Okay, so you observe here, guys, whenever the input is 20, whenever the input is 20, the output is 20 here. You can observe clearly here. Whenever the input is 20, the output is also 20. And whenever the input is 40, the output is also 40. That means if the input value is not getting changed, output value is also not getting changed. Okay, if the input value is get if is something and output was not got, the output input and output values need not be same, they will be different. But the for if the input is always the same, the output also must be always same. You just may might be wondering what is the big deal with it, but I will try to show this. See this now. Well, sum a equal to 100, just I took you like taken like this, df m2 of, where there is a possibility of generating different result for the same input again and again. Let me show you that. X colon int equal to, what I do is here, a equal to a plus x and return a. So now I pass m2 of 10, the result is 110, and again I'm passing 10, it got result 20, for 10 40. So if I'm passing 10 here, I got 110. If I'm passing 10 here, again the output got changed. And if it is 10 again the output got changed. So the input remaining is same, the input value is same, but the output value is getting modified. It is getting changed. For every iteration the value is getting changed. Okay, so these type of functions are called as impure functions. Impure, they're not called as pure. Impure. What is a pure function? A function, for an input it has to produce the same output always. For an input it has to produce the same output always. Okay, that is the meaning of what you call as a pure function. Got it? That is called the meaning of a pure function, guys. Okay, now is it fine? So I write, see this now, this is m2, this is what I've written, and a df. So with what is the logic inside that doesn't matter, guys. Okay, but how it is behaving, that only that matters. So this is called as an impure function, or because this is going to change the value every time. So how shall I define a function so that its output doesn't get changed frequently? It has to be same always. If the input is same, output also must be same always. That is called as a pure function. How can I define a pure function? See this, m3 of x colon int equal to, what I do is here, uh, some val y equal to a plus x and return y. See this, guys, now I pass m3 as some 20, I got 110, again I pass 20, I get 120, again I passed 120. So for 20 is always 120, it is not getting changed. If I pass some 30 here, the output will be some 130, and if I pass again 30, again I get 130, again 130, again 120, 120 for every 20. And for 40, this is called 140, 140, 140. That is if I not change the input, output is also not getting changed. But in the previous case, what is that? See this, m1, m2, m2 of 10, here the value is 110, and if I pass again m2 of 10 again, it is giving 120. So this m2 function is a impure function. Impure, why? Because it is generating different output. Even though input is same, it is generating different output. But in this case, m3 is not changing its behavior. Its behavior is same. That is 40, for 40 it always generates 140 only. Okay, so in this case m3 will be called as a pure function, and m2 will be called as a what function, guys? Impure function. Impure function. Okay, remember that point. So pure functions are very easy. We'll discuss about the details of this pure function and the currying concept in the next session. Just I made introduce you to these both concepts, and in the next session we should discuss about in detail what are they and how they will be used and what is the purpose of them, that we shall discuss about. Okay, now guys, clear? Any questions on this? Is it fine, guys? Any questions in this session? Yeah, fine, guys. If it is fine, let me just wind up the Scala session for today. Tomorrow we shall continue. And So take a break of some 15 to 20 minutes and let's start our Spark session. Okay, na? Fine, guys.